to judge, to measure such a goodness or high quality of your modeling, we discuss about the measure of goodness. So, in terms of database, what is the good model? We should not have any redundant information. If we have such a redundant information, probably it will be very hard to manage and waste of your space. Performance will be degraded. Also, what about the null? So, since relational database model allows the null as the empty value, we can use as many as possible. However, that may cause the problem, like the waste of space or hard to manage your data. So, using this kind of measurement, we discuss about the two approach to make your initial draft of the model better and better. The first approach is informal way, informal guideline. For example, first guideline is what? One relation, one table should have one meaning. If we have the many different meanings or semantic in one relation, what happens? It's very hard to understand. Okay? Also, it may cause several problems. Like when you insert the data, I cannot insert the new department information without at least one employee. Okay? That is called insertion anomalies. And second problem is when you delete the data, sometimes unexpected, unwanted data will be deleted altogether. That is called the deletion anomaly. Third one is modification anomaly, updating anomaly. For example, I'd like to change the HR information. So we need one-time update. But if your model is not good enough, we need to update 1,000 times, 10,000 times. So these are called anomalies. So second guideline is what? No anomalies in your model. The third guideline is what? Why don't you record in mind? It's totally different from the morning class. I think it's time after lunch. So what about the null? So null, we cannot avoid the null value. Okay? Sometimes we need a null to indicate we do not have the value, empty value. However, if you abuse null, so we can combine, we can make whatever we want, then whenever we do not have the data, put the null. Null, keep the space. So waste of space. Also, very hard to understand. So we do better has null, less null as possible. So third guideline is as less null as possible. What about the last guideline? When we use the join operation, which means merge two relations, if your model is not good enough, it may produce unexpected tuples data. That is called spurious tuple, spurious data. So if the last guideline is no spurious tuple, which means your model should be clearly divided into two. Okay, so first guideline is the one relation, one meaning. Second guideline is no anomalies. Third guideline is as null as possible. The last guideline is no spurious tuple when you join. Okay, these are the informal way. Informal way means what? I can just describe, I can just explain. However, computer may not understand what I am explaining right now, informal way, only formal way. So second approach to make your initial model better or good, we are going to learn formal approach, which is called what? Normalization. So normalization means, what is the, in general, what does normalization, normalizing mean? Simplify or segmenting or standardizing. Okay, with matter, we are going to make simpler or smaller or segment the relation. Okay, that is called the normalization processing. So if that each normalized relation is called normalization form. So second approach is normalization. So to do normalization form, we should have something basic utility to do normalizing. So why don't you go back to informal way of the normalization? Informal guideline. We try to keep one relation. We try to make the one relation keep one meaning. How can we make the formalization, the formal way? So that is the reason we discuss about. We bring the idea of what? That idea of function. Function. What is the function? Function is x determine y. Okay? Let's say x is a set of attributes. Y is a set of attributes. X set of attributes determine set of attributes. For example, social security number determine name. Social security number determine ID. Social security number determine address. Social security number determine grade. Something like that. Then this is one meaning. However, as we investigate before the last class, how many functional dependency do you have for each relation? Just one?
No.
Two? There are so many. It's a set of attributes, set of attributes. As long as there is a key attribute, it can be identified. You can make as many as possible. Okay? Among them, what we need is what? Minimum. Okay? Simplified functional dependencies. That is called minimal functional dependency. So we need to find such a minimal functional dependency. How we can find? There is an algorithm. Like the minimal set of functional dependency, how we can find? This is actually the 15.2. But I didn't explain it. I did until the last semester. But it's a little bit hard to understand. Not a little bit, sometimes it's very, very complicated. Because it's totally based on the set theory or number theory. Okay? So, when I explain this one, sometimes many students forget all the things that I explained so far. Then, entirely messed up and chaos. Okay, so this semester I decided not to explain this one, but good news is most of the case you can find the minimal functional dependency intuitively. It's not very hard, but some rare cases, a few cases, it's very hard to identify the functional dependencies. At that time, you can use this algorithm. Idea of this one, I'm going to explain the simple basic idea of the algorithm. For example, this indicate attributes. Attribute A, attribute B, attribute C, attribute D. Okay? B determine A, D determine A, B determine D. These are the functional dependencies that you find from your model, your data. Okay? Our goal is to find minimal functional dependency. They are not minimal. There are some duplicated information. How can we find it? Make as simple as possible. First, right-hand side. Right-hand side is determine the attribute. Single is good. Next is left-hand side. Make simpler. Whether I can take out B. Whether I can take out A. Okay? After that, sometimes you cannot take out, you cannot omit, you cannot remove. At that time, you need to keep it. Okay? In this case, you can take one of them. After that, why don't you compare both or sometimes three, whether there exists duplicate information. Finally, we can get B determine D, D determine A. These are the two minimal functional dependencies in this case. But most of the case, you can intuitively find such a minimal functional dependencies. Our goal is to find minimal functional dependencies. So, for example, this is the example. So this is an invoice for Hilltop Animal Hospital. Okay? It has the date, it has the customer information, and it has the 2 pets and got the vaccination, and amount is blah blah blah. Then we are going to model this one. Okay? First, let's say this is an invoice. This is a simple database, simple information, so probably one entity, invoice entity. What invoice? Relation. So we can directly make the relational schema diagram. That is invoice number. Number will be key of this one, primary key. Any other key? Probably not. The invoice number can be used. What about the Hilltop Animal Hospital?
Customer name.
Actually, that is the hospital name. Who issued this invoice? Right? So it's not changing. We don't have to keep it. Can you understand? It's kind of hard-coded. We have printed the paper.
Yes.
Hilltop Animal Hospital is already printed. That means we don't have to keep such a data. Never change the data in the database. It's kind of constant value. It's not variable. So we don't have to keep such a, what about the IMVO, No, it's never changing. That's not a data in our database. Yeah? What about the date? Yes, we need to keep such a date. What about the Mr. Richard Cook? That is
Patient name.
customer name. Patient is animal. Okay? This is the animal hospital. So it's not the patient name, customer name. Okay? Customer name. What about next? Customer address. The next. It's just one. Okay? Pet name, right?
Yes. Procedure.
I need one bit. Let me. So invoice number, date, and customer name, customer address, and next pet name. Then procedure and amount. What about total?
No.
Actually, we can compute, rely the total from amount. What about tax rate?
No.
It's a fixed. Okay. For example, if you have the many branches of the hospital in Connecticut, in New York, then at the time it can be a variable you should keep. However, this is very simple. As I said, one relation database, so it can be fixed value, so we don't have to keep track. What about the amount owing? You can compute using this one, this one. So these are the whole information that you need to keep track in this database. So this is an invoice. Okay?
So
Yes.
we need to normalize this.
We do not learn normalization yet. Okay, I do not know anything about it. So we will discuss later. Before that, you need to find what? Functional dependency. So why don't you find the functional dependencies? How many functional dependencies? There are so many. Among them, why don't you find the minimal functional dependency from this initial model? Okay? Why don't you bring your any scratch paper, any paper, then try to find. Then, when you find the functional dependency, formal notation is functional dependency name X to Y. For example, invoice, number, determine, and customer name. For example, this is a formal way. You can use this notation. Or another informal way is you can use arrow. Invoice number determine date. Or invoice number determine customer name. This is much easier than formal way to understand. So you can use the left hand side, right hand side. Be careful for head or arrow. Arrow is the right hand side. No arrow means left hand side. Left hand side determine right hand side. For example, if you find invoice number and date, determine the customer name should be like that. So you can use this arrow to represent it. Let me briefly look at the example to represent like this way. Okay, you can use the arrow. But we will discuss that example later. So why don't you draw the functional dependency? So we did not discuss the formal algorithm to find the minimal functional dependency, but it's not very difficult. Intuitively, most of the cases you can identify the minimal functional dependencies. It's a real data. Using the real data, which attribute determine which attribute. In other words, if I know that this value, can I identify the right hand side? If yes, that will be the functional dependency. Then, whether is this the duplicate information or not, if this is new, you can mark it. Any volunteer? Yes. What's your study? What about the date? Date is independent. And also procedure. Any other opinion? Yes. You can write the bottom. Do not erase the bottom. Yeah. The bottom. Okay. Probably some of you guys may have a different answer. So let's check together. So I'm going to use this one. Since inverse number is a primary key, if you know the inverse number, you can find any attribute. So this is actually true. Right? It's actually true. If we have only one functional dependency like that. However, can you find any other functional dependencies? If we know customer name, you can identify the address of that customer. In other words, this address is depend on customer name. Customer, right? So which means customer name determine customer address. So we don't need this one. Instead, customer name determine customer address. Okay? Also, if you know pet and date, because we have many pets in one invoice. Okay? If you know the invoice, you can identify the list of pets. Okay? Also, if you know pet and the date, pet and date, you can identify pet. This is not pet and date. Each pet we have the procedure, right? For what? For this visiting, this invoice number. In this invoice number, and if you know the invoice number and specific pet, you can identify the specific procedure that has been treated. Right? That is this one. So we don't need this. Using invoice and pet name, you can identify the procedure. Similarly, amount. Amount can be determined by probably. In this case, it's the same procedure but different amount. It depends on both pet and procedure. Right? So, for specific invoice and pet, we can have amount. Any other dependency can you find? So one dependency is invoice, determine date, and customer name, and address is not pet name. Okay? Using invoice number, you can find specific pet name. Then, using invoice and pet name, you can identify specific procedure, as well as the amount of money. Also, using customer name, you can identify the customer address. We can find 3 functional dependencies here. Okay? Use it. I know, first time it's not a little bit easy, but think about the idea, how we can separate. So, if you do not know such a way, we should use this minimal functional dependency algorithm. Okay? Actually, this algorithm uses our basic idea. So, to normalize, to make our initial version of model better and better, we are going to use such a functional dependencies, especially minimal functional dependencies. Then, why we adapt functional dependency, minimal functional dependency to our normalization? Any idea? Any guess? To simplify. Okay. What is a guideline? One relation, one meaning. Everybody can understand. However, computer cannot understand. How can represent such a one relation, one meaning? Using functional dependencies. this one will be 1 mini. One minimal functional dependency will be 1 mini. This is only for invoice itself. This is for customer information. Has a different meaning. What about this one? This is a specific listing. Specific treatment. Okay? So this is the idea, fundamental of, if you can get such an idea of the normalization, it's very easy to follow the step by step of normalization. Normalization is nothing but segmenting, dividing, simplifying. Okay? So somebody said the ideal case of the normalization is what? Single attribute. One attribute for each relation, because that is the end of it, basic unit. Okay, so perfect in terms of normalize, no duplicate data. But problem is what? Performance. We have one table. To get customer information, we need to accept this one, we need to join. As I said, join is very, very expensive. Think about, you have one room. When I teach it, normalization, I need to visit his room and teach it. Spend 1 hour. It takes longer time than this classroom. Right? That's the same idea. So we are not going to divide this way. Instead, we are going to group by meaning. How can we represent the meaning? Using functional dependency. So functional dependency is the first step. However, sometimes you do not know, without understanding functional dependency, you can model. I can create a student table. I can create, some of you guys already did in your project, in your work experience. How? Because you already know your database. Also, as I said, normal person, the normal people can do up to third normalization. What is a third normalization? Well, I'm going to explain. So we are going to segment, to normalize by functional dependency. So identifying functional dependency is the first step. Before we start the normalization, actually, this is called unnormalization form. Unnormalization form is like this one. We just identify one relation, initial model. We don't know whether this is good or bad. It's just a start on normalization form. Then we can identify, we can make unnormalization form into first normalization form. We don't know what is the first normalization form, but we apply some condition or constraint or rules. Then we can make first normalization form. So our model is a little bit better than unnormalization form. Next, second normalization form. We don't know what is second normalization form, but we know second normalization form is better than first normalization form. Then how can we make unnormalization to first to second? How can we do that? Segment. Divide. Make smaller. By what? Using functional dependency. How to use a functional dependency? We will see later. Then, third normalization form. Then, BCNF. So BCNF is most strict. In other words, there is no duplicate information. Each relation has one meaning. Each segment has perfectly one meaning. That is called BCNF. So normalization process. In other words, if you already have the BCNF, automatically that should be first normal form, second normal form, and third normal form. It has subset relationship. Okay? So sometimes you can identify directly third normal form. Okay? There is a saying, if you are the normal person, you can do up to third normalization form without understanding any database design. Okay? You can buy group. Everybody wants group by meaning. Nobody wants to put together student and instructor information. If you are asked to manage this university information, probably you will make a cluster group for student, group for instructor, group for staff, group for course, right? That is a third normalization form. Right? Then why we need to do the first, second, third, very complicated. In rare case, a few cases, it's very hard to determine. Okay? Also, you need to have the sometimes conceptual level of design. So that is the reason we start from first, second, third. So in your project, many of students complain, I already did third normalization form. We do not have the case of first normal form, second normal form. I understand, because you are genius. So you can directly to third normalization form. However, for your training purpose, you can intentionally make the case the first normalization form, the second normalization. How can you make that? What is the process?
Divide.
Divide, divide, divide. How can you make the reverse case?
Merge.
Merge. You can merge some tuples, attribute to make the first normalization form, second normalization form. Then, what is the first normal form? Well, what is the second one? We didn't discuss yet. But we know they have the subset relationship. Okay. Then let's start from the first normalization form. Okay. Oh, one more thing. After BCNF, there are more normalization forms, like the multivariate, fourth normalization form, fourth multivariate one, fifth normalization form, joint dependency. They are very, very rare cases. More than 95% of any database design can be covered by up to BCNF. Okay, so in this semester, we are not going to discuss very sophisticated, rare case of the modeling like the fourth, fifth. Instead, we are going to learn up to BCNF. Good news is, third normal form is easy. Everybody can do that. Then, one more thing. That's it. So if you are interested in the advanced normalization form, we can discuss in the advanced database design. Okay. One more thing before we start. So BCNF is better than third normal form, or third normal form is better than second normal form?
No, it depends upon the...
Yes, my question always requires as the depending, right? Depending on what?
The performance of the data inside the
So,
data.
as you know, BCNF most divided, right? Segmented. In other words, to access the data, you need to join. It takes a longer time. So if you feel your system is very, very sensitive, critical for time, performance, at that time you can go back to lower level of normalization form. From BCNF to third to second. That is called denormalization. Denormalization is the reverse way, opposite way of normalization. How can you do that? Merge. If you feel this one and this one work together, then you can merge it. Even though you lose, if you have some redundant information, okay, lose consistency, you can merge. Because performance is much, much more important than such a consistency. Okay, but you need to be careful to keep the consistency in your application program. Okay, that is denormalization. One more thing. In functional dependency, this is a functional dependency, this is a functional dependency, this is a functional dependency. we are going to use such a minimal functional dependency. I know these are not 100% correct. For example, in this case 3. Minimal functional dependency. Plus, we are going to use the primary key information when we normalize it. Okay? What is a primary key?
It's a unique.
Unique and non-null. How do you select the primary key? First, you identify the key in ER modeling. Okay, what is a key? As long as you identify the data, it's called a key. Also, there are super keys. What is a super key? It's a set of attributes that can identify your data. How many super keys? Actually, there are so many super keys. Social security number plus name. So social security number plus whatever. Like any left-hand side of functional dependency. That is called super key. We don't need the super key. Instead, we need minimal super key. Right? We already discussed in relational model. We need a minimal super key. Like the what? For example, social security number in employee. Okay? Or department number in the department. So that is minimal super key. That is called a key. Attribute. How many keys do we have for each relation?
Many.
Sometimes many. Like the social security number plus social security number can be key of employee. Employee ID can be key of employee, right? Sometimes it has many keys. So it's not a key, it's a key. So these multiple keys called candidate keys. Candidate. So candidates should be one or more. Sometimes one, sometimes two, sometimes three. Among them, among the candidate key, you select what? Primary key. Primary key is the only one. Okay, for example, social security number. Candidate key, social security number, and employee ID. You select social security number as the primary key. What about employee ID? This another candidate key is called secondary key. Okay? Then at this time, this is very important. This attribute that belongs to candidate key. In other words, attribute either primary key or secondary key. Any other candidate key are called prime attributes. Okay? What is a prime attribute? Attribute that belongs to keys. Okay, not only primary key, secondary key is also. Then, what about the other keys? The other keys are called non-prime attribute. So you can divide into two. Prime attribute, non-prime attribute. What about this example? What is a prime attribute? Invoice number. Because we have only one primary key, one key. We do not have any other secondary key. So this is the only prime attribute. The other attributes are not prime attributes. We are going to use a functional dependency as well as a prime attribute to normalize it. So there might be the same reason why we consider first guideline or functional dependency, prime attribute. We'd like to find a way to formalize one meaning for one relation. Okay? How can we represent? Using prime attribute, using minimal functional dependencies.
Can you repeat the candidate keys? What is it exactly?
For example, why don't you go back to our basic example company database? In our ER modeling department, D name can be key, D number can be key, right? Both of them are underlined.
Yes.
Right? Then, what can be the candidate key in this case? D number Another candidate key is D name. We have two candidates for primary key. Among them, between them, we need to select one of them as a what? Primary key, because we have only one primary key. However, both of them can be used as the key, right? Because they are unique. They are not null. So, but we select one of them because relational model allows only one primary key. Then candidate key is two of them, and both of them will be prime attribute in this relation. So super key and key. The key is a minimal super key. Among the keys, we need to select one of them as a primary key. The other will be secondary keys. All attributes that belongs to keys, primary key or secondary key, are prime attribute. We need such a prime attribute. That is most important one. Then the other non-prime attribute are non-prime attribute. Okay? So usually prime attribute determine non-prime attribute. Not always. I didn't say the should. No. Always. The most of the case, prime attribute determine non-prime attribute. So we will see the case. Okay, so prime attribute must be a member of some candidate key, any key. And non-prime attribute is not a prime attribute. Then we are going to start from first normalization form. We have unnormalization form. This is not normalized. We don't know whether this is good or bad. We need to normalize it. The first step is a first normalization form. First NF. In first NF, we are going to investigate attribute by attribute. We will check attribute, okay? Then what we need to check? Whether attribute is atomic. Atomic. So we discuss about the atomic in relational model, which means single valued one. Okay? The reason is, since relational model cannot take care of multi-value, that is the only reason. So, first normalization form is to check attribute by attribute, whether they are single, whether each attribute is a single or not. So, first normalization form does not allow So first normalization form is atomic the attribute. In other words, no composite. We do not allow the composite attribute. There's no way to handle in relational model. No multi-value. We cannot handle multi-value data like the D locations. So no, it's not possible. So no nested. What does nested mean? For example, here, actually, how many paths for each tuple? 2 paths. Nobody asked me. It's not possible actually in relational model. Okay? You wanna go back to the example? This one. How many paths? 2 paths. How can you represent the 2 paths? No way, actually. It's not possible. In case you have such a group of multiple values, it's called a nested tuple. It's a relation inside a relation. Nested. It's not possible. So first normalization form allows only single valued one. Atomic value. In other words, no composite, no multi-valued, no nested. Okay? That is the first normalization form. Okay? So first normalization form allow only single value or atomic. So let's take a look at the example. Okay. So we have the department relation as an initial. Do you think this is the first normalization form? D name, D number, manager underbar social security number, D location. In first normalization form, you don't have to worry about the functional dependency. Only take a look at each attribute.
No.
Whether this is single valued or not. What about D name?
Yes.
Yes. D number?
Yes.
D manager social security number?
No.
Yes, we have only one manager for
It's
department.
related to the employee entity.
We do not have employee entity here.
Just one.
It's just one example. Okay, D main department. Okay, so just take a look at this example. So D manager social security number is a single value. Okay, it's okay. What about the D location? This is a multi-value. So we can say this is not in first normalization form. We need to address it. We need to change into first normalization form. How can we do that? The only solution is
To create a relation.
segment. That's the only solution in normalization form. Just a segment, just a divide, just this way. So how can we segment? We can take out the delocation. Or in this case, we can make the multi-valued one as a single valued attribute with D number. For example, D number plus location is the primary key. Then we can have single value. This is another solution, but this is not a good solution. Why? We have redundant data. Actually, this is not a good solution. So I recommend the only solution is segment first. After you segment it, if you feel we need to merge, that is the denormalization. So this is not a good solution. As you can see, we have redundant information, even though that satisfies with first normalization form. So what can be the solution? We can take out the location. So we have department relation and department location. Can you remember the relational model for company? We have separate department location. Okay, that is the reason. It's the same thing. So don't worry if you miss the step. Probably step 7. Even though you missed the step 7, probably when you normalize your model, you need to check this one. Okay, that is the first normalization. Any question? It's easy. So we can check just the attribute by attribute.
Professor, delocation at this form is applicable in the database?
This one?
This one.
So this is our model, relational model. So we need to check whether this is good or bad. What is answer? It's not good. It's bad. Why? It doesn't follow first normalization form. Okay? So we need to do something. Something is segmentation. Divide into 2. Okay? Then this is another example. The employee underbar project. So let's say this is our initial model for employee underbar project. Project is that one represent nested relation. So we have for each social security number, we may have many projects. Project A, project B. For each project, we have the number of hours. Then, for example, this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. John Smith has 2 projects. Is it in the first normalization form? First, yes one. First normalization form. Yes?
No.
No.
What is the question, Professor?
Is it in the first normalization form? No. Why?
Because it has multi-value.
It has multi-value. What? Nested relation. Okay? This is a nested relation. We need to do something. What is the solution? Segment. So we can take out P number plus hours. Like the P number plus hours with social security. We should identify. And this one is social security number and e-name. Let's go back to record the informal guideline. What is the first guideline?
One relation.
One relation.
One relation, one meaning.
Meaning.
One relation, one meaning. It's the same thing actually, but it's a formal way using normalization form. Since it has two different meanings in one relation, that may cause the problem. So we need to address through the normalization process. Okay? Then that is the first normalization form. What about this? Is it in the first normalization?
No.
No. Why? It has nested. So we need to take out pet information. That is the reason. Let's go back to this example. Yes. So this is the unnormalization form, but this is the nested. The other actually, okay, single, 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 but this is the multiple nested. So we can divide into two. One is invoice, another one is invoice underbar pet. So invoice number, pet ID. Determine we do not have the pet ID, but we use instead of pet name, we intentionally put the pet ID. So this is the first normalization form. Okay. The second normalization form is a little bit more difficult to understand than the first normalization form, but that doesn't mean it's very difficult. Second normalization form simply full dependency to the keep. Let's see the example. Full functional dependency. So we have, for example, employee ID and department project number and e-name and hours. That is the primary key. First, we need to find the functional dependency from now on. Functional dependency. How many functional dependencies can you find from here? First, employee ID determine employee name. What can be social security number? And project number determine. That should add one more thing to make it clear. P name. 2. Right? And employee ID plus project number determine hours.